Now, if we wanted to take a given function and write it in vertex form, then analyze the function, that might be a little more work. In these cases, we're going to have to use completing the square, which is something we learned before. That's going to come up again. So remember, when we were completing the square, we just look at these first two numbers. We have x squared plus 2x plus something is going to give us our perfect square trinomial. And that's going to be the same as x plus something squared. So always look at this number, our second middle number there, and say that over 2, so 2 divided by 2 gives us 1. So 1 is the number we put in our binomial. Now when we take that number, 1, and square it, gives us 1. That answer is what goes in here for our perfect square trinomial. So we rewrite our function. We have y equals x squared plus 2x. Here we did plus a 1, so we have to add 1. To make sure we're not actually changing the equation, we have to subtract 1 as well. And we're still adding the 4 that we did before. This piece here becomes that perfect square trinomial, which we can change into a binomial of x plus 1 squared. We got that from over here, remember. We still have our minus 1 and our plus 4. Negative 1 plus 4 comes out to a positive 3. Now we have our function in vertex form. So this is what we're looking for. And remember, we attain that by completing the square. Once we have it, things we want to be looking for are the vertex, which we remember is at minus h plus k. So we would say that it would be at minus 1, 3. That's where our vertex is. Our axis of symmetry, again, is where x equals, we just use our x coordinate of the vertex, and our y-intercept. Again, if we wanted to use this equation, we'd have to plug in 0 for x, or it might be easier just to look back at this equation from before and see that it is 4. So those are both valid ways to determine that. So we have found our function in vertex form, and we analyze it, finding our vertex, the axis of symmetry, and the y-intercept. Sometimes we're given a function in standard form and asked to put it into vertex form, then analyze and graph the function. So in this case, we have y equals negative 2x, or negative 2x squared, should I say, minus 4x plus 2. So I'm going to give us a little space down here to work with, because we need to get this first into vertex form before we can do anything with it. Now in this case, because we have this negative 2 out front, but we can also recognize that negative 2 we can pull out of all of our pieces here, all of our terms. So we're going to say y equals, we'll factor out that negative 2, say x squared plus 2x minus 1. And again, we know that's true because this negative 2 times the x squared is our negative 2x squared. Negative 2 times the positive 2x gives us our negative 4x, and negative 2 times negative 1 is our positive 2. So we can make sure that these all fit and these all work. From here, we're still not into vertex form. We need to complete the square just on this little piece. So we have x squared plus 2x plus something. It's going to be our perfect square, x plus something squared. So remember, we always take this value here, and we divide it by 2, which means we have 1 at the end. So it's going to be x plus 1 squared. We need to take this value of 1, square it, which gives us 1. This value is what goes in to this piece here. So now we have our perfect square binomial and our perfect square trinomial. From here, we can rewrite it as y equals negative 2 times x squared plus 2x, and we want to make sure that we add the 1 that we got from right here, and we don't want to change the equation, so we have to subtract 1 as well, and we still have our minus 1 from before. All of that is still being multiplied by negative 2. So we simplify this down, say y equals negative 2 times this piece here was our perfect square trinomial, which we can change into our perfect square binomial. So we would say x plus 1 quantity squared. We still have our minus 1 out here. That still is also being added to another minus 1. So in the end we say minus 2 and close our parentheses because that's still all being multiplied by negative 2. That's not quite into our vertex form yet, but we're getting much closer. From here we say y equals negative 2. We distribute it, negative 2 times our x plus 1 squared, and negative 2 times our negative 2 is 4. So in this case, here, we now have our equation in vertex form. So I'm actually just going to bring this up with us. And so now we're looking at the equation that we want to look at. We're looking at it in vertex form. From vertex form, remember we want to analyze it first. So we'd say our vertex is minus h plus k. So negative 1, 4 is where our vertex is. Axis of symmetry, x equals negative 1, or it's the x value of our vertex. Y-intercept, we could either plug 0 into this function, or we can look back at our original and notice that it's just 2. So both are, again, both are viable options. So now we have our vertex, axis of symmetry, and our y-intercept. Now we need to make our table. We'll center it around our vertex, so we put our negative 1 right here, which kicks out a 4. Then we want the numbers that are going to be around that. So like negative 2, negative 3, negative 4, or going one bigger, we'd have 0, 1, 2. Well, we know that when we have 0, it'll be 2, because that's what a y-intercept is. And we also know that since it goes through the axis of symmetry, and 0 is 1 away from 1, and negative 2 is 1 away from 1, that these ones are going to be the same value. So it looks like we only have a couple more values to obtain. If we do negative 2 times, we'll plug in negative 4 for x, so negative 4 plus 1 squared plus 4. That's negative 2 times negative 4 plus 1 is negative 3 squared, and still plus 4. Negative 2 times the amount negative 3 squared is 9, and plus, 4. Negative 2 times 9 is negative 18, still plus 4, which in the end is going to give us negative 14. So that's that value there. Clear this up, give us some more area to work. If we plug in negative 3, say plus 1 squared plus 4. So again, we're just plugging it directly into our equation from up here. Now we say negative 2 times the amount. Negative 3 plus 1 would be negative 2 squared plus 4. Negative 2 squared is going to be 4. So negative 2 times 4 plus 4. Negative 2 times 4 is negative 8. Negative 8 plus 4 is going to be negative 4. And again, because we have that axis of symmetry, we can just use the same exact points for these ones. So now we look at our graph, and we'd say that we're at negative 1, 4 is going to be our vertex. At negative 2, 2 we have a point, and at negative 2, or negative 3, negative 1, 2, 3, 4 we have a point. And our negative 4, negative 14 will be somewhere way down here. Looking at the other side of our parabola, looks like our y-intercept is 0, 2. There's a point. That if we go to positive 1 for x value, our y value is going to be negative 4. And positive 2 for an x value is going to give us a negative 14 y value. So this is what our parabola is going to, oops, it goes through this point. It's going to be looking like. Our axis of symmetry is that x is negative 1, and our y-intercept is over here at 2 still. So that's how we would analyze and graph that function after changing it into a vertex form. When we want to write an equation for a parabola whose vertex is given at 1, 2, and it passes through the point 3, 4. Well, this is going to be a lot easier in vertex form than it would in standard form. In vertex form, we would say y equals a x, remember, minus h plus k. So we have our plus 1 here, so minus h squared plus our k value of 2. So we just plugged in our vertex into our vertex form. Now from here, we still need to solve for a, but we know that it goes through the point 3, 4. So what we can do is plug in these points. 4 equals a times 3 minus 1 quantity squared plus our value of 2. So we plugged in our vertex and our point. So now we can solve for a. So we would say then that 4 equals a times the amount 3 minus 1 is 2 squared plus 2. From here we carried out some more. We say 4 equals a times the amount 2 squared is 4. So a times 4 plus 2. At this point, we subtract 2 from both sides, which is going to leave us with 2 equals 4a. And then we would divide both sides by 4, which is going to leave us with 1/2 equals a. Once we know what our a value is, we look back at the equation we were looking at before, just plug that into our vertex form. So y equals 1/2 times the amount x minus 1 squared plus 2. And so this is our vertex form equation for the parabola with the vertex at 1, 2 and passes through 3, 4. And it looks like that's the end of it. So if there are any questions, be sure you are asking those. Otherwise, may the odds be ever in your favor.